Good morning. Let's discuss the JEE-Mains 2013 paper as far as the maths part is concerned. We have taken problems from set P. This was the first problem in which two planes were given and you need to figure out the shortest distance between them. You can clearly check out the planes are parallel. In such a case, all you need to do is you have to manage this left hand side part in both the equation exactly matching. For that case, you need to divide the second plane with 2. If you do that, then there is a formula as C1 minus C2 by square root of sum of the direction cosines squares of normals to the two planes. If you follow that, C1 for this case is minus 8, C1 for that case is then 5 by 2, so this is C1 minus C2, that would give you this expression where a square, b square and c square is this much. You check up, this quantity is then going to simplify to 7 by 2 units. This was one of the option. I believe that was the third option in that paper. Okay, let's move on to the second problem, that is this. Let me give you some idea about that. In that problem it was given that a firm is manufacturing 2000 items in the very beginning, and after that it is given to you that it's being estimated that rate of change of production with respect to additional number of workers, that is X in this case, are connected in this way. That's a rough estimation they have made. After that it is given that if firm employs 25 more workers, that is given to you effectively that X is 25. This is the additional number of workers are being introduced. Then on the basis of which what is a new level of production, that is what you need to compute. So for that case, just you need to make this assumption that, say, if we have taken X as 0 at that time, this production is going to be 0 at that instant. Let's consider the required production is P, and if you take the operator to the other side, that is going to then vary from 0 to X. So by this you can clearly check up, P becomes this quantity. So basically this formula is going to give you the extra production because of this 25 number of additional workers. So if you place X as 25 in this case, you can clearly check up that P becomes 1500. The 2000 was the original number of items were there. This is in addition to that. So total number of production, the total number of items is going to be 3500, which was the third option in that paper. Okay, then the next problem is this, that in which it is given to you that there are two sets, set A and set B, with cardinalities or the cardinal number as 2 and 4 respectively. And then in that problem you are supposed to figure out number of subsets of this A cross B set with 3 or more number of elements. This was the problem. I mean, in that case, it's better to consider first of all the cardinality or the cardinal number of this A cross B set. That should be obviously 2 into 4, that is going to give you 8. So for a set in which you have 8 number of elements, total number of subsets is going to be 2 to the power 8, because each and every element has got two choice, either it's present or it's not present in that. Because of that, this is the total number of subsets. But we are actually looking at number of subsets with 3 or more number of elements. So it's better in this case that we start eliminating unwanted situation, which is the empty set, that is only 1, then the subsets with exactly one element, and subset with exactly two elements. This is what is going to be the final quantity, because 3 or more number of elements are required in those subsets. So this is what is going to be the final answer, which is what is 219, and that was the third option in that problem. Okay, the next problem was this, that in which, if you observe, there were two straight lines given in symmetrical form, and it is being told that those lines are coplanar. On that basis, we have some options depending on the values of k. So for that case, if you want to make two straight lines coplanar, obviously then in such a case, what we need to do is we have to manage the shortest distance between them should be 0, or you can say using the direction ratio of this line and direction ratio of the vector joining these 2 points, that should be coplanar because the lines are coplanar. For that case then, the vector which you end up getting along this line would have these components, vector along this line would have these components, and a vector joining one fixed point on this and the fixed point on this, that is these are the 3 components of 3 vectors which are going to fall in a plane, because these lines are coplanar, so their STP has to be 0. So this is what you need to manage. If you simplify this matter, you'll end up getting a quadratic because of the obvious reason, and that quadratic has delta positive, which implies that there are 2 different values of k acceptable. So we can conclude that this is what is the correct option of this problem. Okay, in the 65th problem, and these are the 2 vectors given to you, and using them we need to consider a triangle. What we need to figure out in that case is the length of the median through A, and we are aware of the value of this AB vector and the value of this AC vector. We know this thing, that this vector AM is going to be clearly AB plus AC by 2. So once you figure out that vector, I guess nothing left in that problem, you can easily manage. So you can check up, it is 4i this is what is a vector AM. We are supposed to figure out the magnitude of that vector AM, which is clearly 33, root 33. In the 6th problem, this was the information given that this cubic equation should have 2 distinct real root in this interval. Assuming that that information is correct, we need to figure out something about k. I mean, what kind of values that parameter k should be taking so that this statement works. For that case, since it's a cubic expression, if I consider this left hand side as a function f of x, you can clearly check up its derivative is more than or equal to 3. Effectively, it's positive for every value of x. We can then safely say that this function, that cubic polynomial, is a strictly increasing function. So that kind of function can cut any horizontal straight line in only one point. That can't intersect x-axis then in 2 distinct points in any interval. Nothing specific about 0 to 1. You take any interval, you are going to have no such k. I guess that was the fourth option of that problem. It's given k does not exist in that. Okay, in the seventh problem, this was the information given that we need to add up these numbers till 20 terms which follow the same pattern. And in this kind of problem, we have a general way of dealing with it, and that approach is that whatever digit we have here, just keep on repeating, we take that out and we divide and multiply with 9, because if you do that, this expression becomes which is something which you can relate with a geometric series, and for that case we have a formula. And for example, in this case I can write it as 1 minus 0.1, this as 1 minus 0.01, etc. So if you observe in this way, if you proceed ahead, you are going to have this 120 times, and then after that whatever the thing we need to subtract, that you can check up clearly, they are in GP, which can be easily managed. We have a formula for it. I mean, 0.1 is the first term, then we have this quantity as the common ratio. We have 20 terms in it. This is the quantity which we need to simplify out of 20, and then we need to multiply that with 7 by 9, which is, after simplifying it, you can clearly check out, this is going to match with the third option given in that problem. Okay, in the eighth problem, it is being told that an incident ray is following this path, and along this line it's moving, and it is being reflected from x-axis. What we need to do in that case is we need to figure out the equation along which reflected ray is going to move. One thing, if you clearly check up, the slope of this particular line is negative 1 by root 3. Effectively, then we can conclude that this particular angle is 150 degree. If that is 150 degree, this is then obviously 30 degree. This is 30, this quantity then has to be 30. By symmetry, you can say this. If this particular angle is 30 degree, you can clearly say then the slope of that reflected ray is going to be 1 by root 3. And that line, that reflected line, has to pass through this point, which is nothing else but root 3 comma 0 as it is given. So you can clearly write down that equation of reflected ray as this, which is simplifying to the second option given in that problem. Okay, in the ninth problem, this was the information given that two straight lines are given along with that parameter k. What we need to manage is we have to conclude something about values of k, under which value of k, what we have to manage is that these two straight lines should not have anything common. Effectively, they should not have any solution. So for that case, you can follow Kramer's rule, but I would say, since we have to manage that those lines are parallel, under that situation only they'll have no solution. So what I am doing in this case is, I am first of all making them parallel. For parallel case, what we have to do is we need to manage this particular situation, that their slope should be same. So I am just comparing the coefficients of x and y. Further, what we need to do after this is, this ratio should not be equal to this 4k by 3k minus 1. Then and only then this is going to be parallel lines but different lines. I guess as far as the value of k is concerned, we can easily figure out from this, because it's a quadratic equation. You'll end up getting two values of k, which are, you can clearly check up. It is, this is what is the quadratic you end up getting, which implies k equal to 1, 3 are the roots, and k equal to 1 is going to make this ratio 2. k equal to 1, if you substitute that here, this is also this quantity is also turning out to be 2, implies then k equal to 1 is not valid. K equal to 3, if you try out, it is 12 and it is 8. So that ratio is not turning out to be 2. So k equal to 3 is the only acceptable value under which situation these lines are parallel but different. They are not coincident. So they'll have no solution only for this particular value of k, which is the option 2. Effectively, we have only one value of k for which those lines are parallel. Okay, in the 70th problem, this was the information given that we have two quadratic equations and it's being told that they have one common root. Under that situation, you need to figure out this particular ratio, a is to b is to c, and it is given further that a, b, c are real on this. One thing in this case, if you observe that this quadratic has got discriminant negative, that is 4 minus 12, which is minus 8 effectively. That implies this quadratic has got complex roots. Obviously they are in pairs then. And further it is being told that this equation also has one of the common root. Between the two quadratic you have one common root. Implies that this equation must have one common root, and that common root is complex, and a, b, c are all real. Implies then if this quadratic has got an imaginary root, then the other root has to be imaginary. Not only imaginary, that should be its conjugate pair. Implies then this quadratic and this quadratic can't have exactly one root common. They should have two roots common if they have one root common. Implies that these two quadratics are same. They should be identically matching. Implies then a is to b is to c should be directly proportional to 1 is to 2 is to 3, because the two equations are perfectly same. So this implies the first option given in that problem. Okay, in the 71st one, the information what is given is that a circle which passes through this is touching x-axis at this particular point. Then on the basis of this information, there were four options in which we have various coordinates. We need to check out which coordinates satisfy that circle, which is actually satisfying all these conditions. Now for this case, since circle touches x-axis at this point, the best way to deal with that is that you consider this as a point circle, and then you consider this particular line as a tangent to that point of circle at this point itself. So if I consider this particular family s plus lambda l equal to 0, where y is representing x-axis, this is that family of circles which touches x-axis at this particular point. The required circle is obviously then a member of this, and lambda, which you can figure out just by putting this coordinate in this equation, which you can clearly check up after putting 1 minus 2 in this. Lambda becomes 4. If lambda is 4, we know the equation of that circle as in this is what is that required circle. You can clearly check up in among those four options is only the third option which satisfies that relation. Okay, in 72nd one, there are the two informations given that x, y, z are three variables which are in AP, and tan inverse x, tan inverse y, tan inverse z are also in AP. On that basis, we had four options in which we have some relationship between x, y, z, which you need to check out which one is correct. For that case, obviously, by this you can certainly write down this statement, and if tan inverse x, y and z are in AP, implies this condition, which you can further simplify it as using some inverse formula. After this step, you can clearly check out if I take tan on both the sides, tan inverse get rid of, and after that 2y and x plus z are already same, so you can remove this also. The two denominators are same, implies then y square is equal to xz, which implies xyz are in GP also, in addition to the fact that they are in AP, implies that this kind of situation is going to work only and only when variables are all same. Three numbers are in AP and they are in GP simultaneously. If such a situation is there, variables has to be equal. Same thing you can say for AP HP, GP HP pair, that variables must be same, which is then satisfying the first option criteria. Okay, in the 73rd problem, you have a certain reasoning problem. You have one statement given as this, that this is a fallacy, and the second one is this is a tautology. What you need to check up is that they are correct or not. If correct, then second one is a proper explanation or not. By the truth table, you can clearly check up that the first statement is a false statement and the second statement is a correct statement, which implies then the fourth option is correct for this particular problem. Okay, in the 74th problem, this is the information given that integral of f is a function psi, and then we have four options based on this information that this integral is matching with which particular option. We have to utilize obviously that statement. We can clearly check out this x to the power 5, we can connect that with the quantity given inside this function, and after that if I consider this as the substitution in this integral, you can clearly check out this part, we can utilize it as 1/3 of that dt, and this part is certainly tf of t. After that you can check out it's a product of two functions out of which one is algebraic and it is t. So using by parts, taking this as the first term, you can certainly write down the result as integral of ft, which is certainly psi of t, minus then the derivative of this function t, which is going to give you 1, and then integral of that f, which is psi t, and then d of t. This is what is something which you are going to left with, and since we have taken this as substitution, all you need to do is that you need to substitute t as x cube. If you do that, you end up getting the answer as the third option. But remember, when you are going to substitute t as x cube, this is going to be x cube, but dt is going to be then 3x squared dx. This you need to take care of. There is something which is important. Dt you can't take it as simply dx, because t is x cube, so dt is going to be 3x squared dx. If you correlate this with those options, you'll find that the third option is matching perfectly with this. Okay, in the 75th one, this is a limit which you need to evaluate. You can clearly check out if you enforce the x approaching 0 limit here, this whole thing is in 0 by 0 form. And this part, the way it is given, if I have somehow x square here, then this is a standard limit. You can correlate this with 1 minus cos kx by x square, which is k square by 2. Effectively then in this case it is 2 square by 2. But then since we have taken this extra x, so we need to cancel it out. If I take that x with tan of 4x, we can certainly say that this part, this quantity is nothing else but then 4, because we require a 4 here further. And after that, if I enforce the limit on this part, that is clearly 4. So this is what is a limit, which is simplifying to 2, which is the fourth option given in that paper.